So I think this is the daily problem. I'm just started reading it and writing it in separately in the notepad. Before and that eighth class a total of but number of you are also it is a brilliant students that are guaranteed to pass the exam of any class they are assigned to. You want to so you want to assign each extra students in a way that the maximizes average pass ratios. So we need to Shen. So we need to maximize the average pass ratio. Uh, the pass ratio of the class is equal to the number of students of the class that will pass. So pass ratio equal to they are given I think give the total number of students in the class. The average pass ratio is the sum of pass ratios in the class divided by the number of class. So pass ratio of let's take all the classes school as a variable. Now then I equal to it be I of 0 divided by classes of I and for 1. That's right. Equal to number of students in the class that will pass the divided by total number of students in the class. So yeah, pass by total. Then pass pass ratio of school of I. No, it will be total, right? Pass ratio of school of I equal to sum of pass ratio class. So pass ratio class should be initialized in RA, I think, divided by len of you could say classes. This is the thing. So we need to maximize the pass ratio. Where we should assign the two. It should be is it should be the greedy. Is it arranged in some format? I think I have no idea. It's written the 5th actually will be accepted. So is it any mathematical steps in the 2D array? I don't know. Is it DP? My first thought is it be greedy. Need to arrange it in some way. So we have extra two students. If we arranged those in the poorly performing classes, so we could like take the difference 3 4 5, yeah, take the difference. So we could what if it is higher. So what I'm thinking is this is a solution one. Extra students to the I whose ratio class is maximum. If you arranged it at maximum means then I think the total will be maximum. That's the only thing I could think of. So if I don't know, I'll just see the hint. Pay attention how much percentage change when you add a student. If you keep adding a student, what happens to the change in more students you add, the smaller the change in post ratio becomes. So should we do like 1 1? No need for 2. Here 1. I know that since the change in post ratio is decreasing with most students, then the very first student you add to each class is the one makes the biggest change in post ratio. Okay, so at each step you need to calculate the post ratio for all this. It should be n square, right? Then because each class post ratio is weighted equally, the it always optimal to put the students in the class that makes the biggest change among all the keep the max heap of the current class sizes and order them by changing the pass ratios. For extra student, take the top of the heap, update the class size, put it back in the heap. I have no idea. Yeah, greedy, I think. So, okay, I got heap of should be show class pass comma total. I think this should be the heap. Mm, no, if it comes means it should be negative, right? Negative. So highest will be here. What if the what even if the highest is here? I have no. I think I have no idea. So let's, for fun, calculate the example is 0.5 comma what is 3 by 5? 3 divided by 5 is 0.6 6 comma 1 1, right? Then the one we need to add is the smallest one, right? Then it should be min heap. If so, it should be min heap. Max heap, how is it coming? Like, no, they're saying, okay, okay, let's have a function to, so def calculate ratio. So pass and total, return pass by total. It should be there. while greater than 0, we are trying to assign everyone, right? Then if not, heap while len of heap is not equal to len of classes heap dot heap. So let's have I be over here. Heap is not is equal to len of classes. Let's just push everything first. I'm trying very hard in greedy method. Um, so pass ratio plus pass calculate ratio val equal to calculate ratio of classes of I of 0 comma classes of I of 1, then heap dot heap push heap. Come on, why should we have it as a heap? Let's have it as h. No, sorry, I forgot the syntax. Heap q, it will be heap comma val comma classes of I of 0 comma classes of I of 1. I plus equal to 1. So after pushing it, we'll be going, it will be arranging by minimum heap, right? What is 2 by 3? 2 divided by 3 is 0.66, will be there. Then 3 divided by 5 is, okay, then 4 divided by 6 is 0.66 plus 0.66 plus 1 plus 0.66 plus 1 divided by 3 equal to 0.777833. I think it's working pretty good. Yeah, I think this thing will work. Ratio comma p comma t equal to heap q dot heap pop heap heap q syntax. I think heapify. I don't know. I don't know about that. Heapish. I know. Q dot heap pop. Yeah. np comma nt equal to p plus 1 t plus 1. So let's arrange one by one. So classes total is, my god, it will be too heavy, I think so. Let's try it first. np of nt plus t plus 1 t plus p plus 1 t plus 1. Then afterwards let's include new ratio equal to calculate ratio of np comma nt. Then heap q dot heap push uh, heap q dot heap push. Then we need to put heap comma new ratio comma np comma nt. So it will be like this. After pushing all that, then we need to retrieve it, right? So then what we need to do is, we have it in an array, everything in an array, right? uh First just let's return. heap dot heap pop heap, then dot append ratio. Okay, after appending it, we need a return sum of arr by Lena classes. That's what we wrote. Let's check what is happening. Why is it not okay? I thought it will work. It's a small margin of error. What is this, man? I think I give up, man. So this is the step I, after writing my own approach, if it's not working, I use GPT. Extra student, we should put them in the classes that yields the largest increase, but not just one with the lowest ratio. Your implementation is that you're pushing to heap based on current ratio instead of gaining to. So at each step I need to check which, right? I but the smallest one, we restore the gain from adding a student. So gain is p comma t, right? Then p plus 1 by t plus 1 minus p by t. So why is it? Gain is, yeah, understood. At each step it will work, right? Minus gain of p by t, 80 for p by t in classes. GPT is equal to heap pop. Okay, and such a easy man. So I think I'll try to heap equal to minus gain of p comma t comma p comma t for p comma t in classes. This is the correct syntax, right? No. So classes, okay. Heap q dot heap p phi heap. This is good. Then for in range extra students. So we'll be iterating to the extra students. While iterating through, we can see which yields the maximum, right? So gain comma p comma t equal to heap q dot heap pop heap, right? After popping it, we can check. It gives the new gain, so we'll increment it and calculate the gain again. So comma nt equal to, so t plus 1 new gain equal to gain of np comma nt. Next we need to put heap q dot heap pop push heap comma new gain comma np comma nt. After doing this, arr equal to for in range len of arr dot r comma p comma t equal to heap q dot heap pop heap arr dot append. We need to calculate that p comma t. Return sum of arr by len of classes. Okay, what? List and tuple. Okay, I listed it as list and now I'm giving it. Should I given it as a list itself? So it should be so it is already sorted, right? The same thing is coming. Sum of p by t. Okay, I need to store it as negative gain so that the positive will be at the first. Sorry. Okay, yeah. So let's submit it. Sheesh, did it, man. After a long time, I'm resuming my streak. N plus k log n. Let's try to justify log n for heap and for the k times we are doing it. Then the n is separate. in a separate, then okay, for the sum. Okay, so I think that is the thing happening. Okay. Log and update per students. Give extra students to class time maximum increase. Could you explain me the time complexity? We'll be building the heap. This is n. Okay, so this is yum log n. Okay, understood. So it will be, let's have the time complexity in here. Okay, sure. That's all for today's video. This is I'm trying to do. Maybe sometimes I'll be trying to do. Sorry. Sometimes I'll try to do the competitive programming questions also. So let's see. Thank you.